Hello, grade 11. So, I want to clear some misunderstanding or some confusion about the form of y equals a of x minus p whole squared plus q. And the ones I want to focus on is this a over here and also the minus p in the middle. Okay, so first of all, I'm going to talk about y equals to the a of x squared. So I'm going to start with the simple y equals to x squared. This is our simplest quadratic equation. And so what effect does a have on this x squared? I'm going to start with, I know the textbook says that there are two conditions, if a is bigger than 1 and if a is less than 1. So let's do the first one. If a is bigger than 1, okay, and I've always talked about this a as a multiplying scalar. And so I'm going to use a simple example. So if a is bigger than 1, so for example, y is equal to 2 of x squared. Okay, so now my a is going to be 2. Okay, 2 is bigger than 1. And so what this means, this 2 is a multiplying scalar to x squared, to this whole x squared. Okay, so whatever x squared the value is, we will then multiply that by 2. So for example, on my original, in my y equals x squared, if I put in 1 into x, it's going to be 1 squared. And then now in my y equals to 2 of x squared, if I put in 1 into x squared, it's going to be doubled, multiplied by 2. And so my resulting value will then be 2. So if I look over here at my graph, I have y equals x squared over here. 1 will now become 2. And then if I put in 2 into the x, it becomes 2 squared, which is 4. 4 doubled will become 8. So 2 will be at 8. And then 3 squared is 9. 9 doubled is 18. So at 3, it will become 18. And same for the negative side. It's going to be 1. It's going to be at 1, negative 1, 2. And then negative 2, 8. And then negative 3, 18. Now, what this actually have as an effect on the graph is I'm going to now copy my original graph. This is the y equals to x squared. I'm going to make a double of it, and I'm going to put it right on top. Okay, so this is the original. Now, what the effect of 2 has on this x squared? It doubles the whole graph, which means every single value is double, which means I'm going to stretch this graph up until all the values are actually double. So if you look over here now, into my new graph, this is stretching it. Okay, I can change the color? No, I cannot change the color of this graph. So I have stretched this graph. Now it's equal to, y is equal to 2 of x squared. That is what this graph is. I have stretched it. I have expanded it. And I think, yes, the textbook does use the terminology. There is a vertical expansion. And then there's the multiplying scalar of 2. Expansion of 2. So there is a vertical expansion of 2. That means that I have stretched it out to double the original values. So that is if a is bigger than 1. Now I'm going to go over to what if, for some reason I can't change my color over here. Can I change color? No. Okay. So what if, okay, I can change the color. Good. So what if a is less than 1 now? So for example, let's say a is half, okay? So we have y is equal to half of x squared. What this means is every single value is now halved. So originally, if I have 1 in my x, 1 squared is 1. Half of 1 now becomes 1. So if I go into my graph here, the value at 1 will be half. And then the value at 2, 2 squared is 4. Half of 4 is now 2. And same as 3. 3 squared is 9. but half of 9 is 4.5, which is over here. And so what this actually have as an effect on this graph, I'm going to take my original graph, I'm going to copy it, make a duplicate, I'm going to put it right back on top. So what happens here is I'm going to compress it. I'm going to push it down so that all the values are now half of the original. Okay, so what this does is there is a compression. Okay, so this is y equals to half of x squared. Now, why does it look like it's wider? Well, it's not actually wider. It's the same width, but it's just compressed downwards. So kind of like if you have a very full recycling bin, a paper recycling bin, and it's the paper is all the way at the top. You know that there are some people who crunch up paper rather than put in the plain paper flat. And so what you can do is you can compress it. You can push it down until the value at the top, or the height of the recycling paper, is now compressed to a lower height. Okay, so that's the meaning of half of x squared. Okay, so, or if a is less than 1, then we say that there is a vertical compression of half. Okay, vertical compression. It's compressing and then to half the values. Okay, so if a is bigger than 1, it's expansion. If it's less than 1, then it's going to be a compression. Okay, so hope that clears up some misunderstanding about the a over there. Now I want to clear up some misunderstanding on the minus p. Okay, so now let's talk about y equals to, I'm going to get rid of the a right now, just x minus p whole squared plus q. Now for the plus q, you all know it's very simple. If the value is positive, it's going to be a upward shift. If the value is negative, it's going to be a downward shift. But what about the p? Now this, don't forget that this general term, this equation over here, the minus p, is minus, which means that if p is positive, okay, so let me go over here. If p is, oh, what happened there? No, not ink to shade. If p is bigger than 1, if p is, no, bigger than 0, if it's positive, and let me put, for example, e.g., p is equal to, let's say it's positive 1, okay? Now I'm going to put the positive 1 into my equation. It's going to be y equals to x minus positive 1 whole squared plus q. Now the minus will then go into the plus, and overall our equation will be y equals to x minus 1 whole squared plus q. So if our p value is greater than 0, if it's greater than 0, that means our resulting equation will be x minus 1 minus. Then, as I have been saying in my lessons all along, if this value over here is negative, if it's minus, then it's going to be a right shift, which is the same as what the textbook says. But the textbook says if p is greater than 0, then there would be a right shift. And similarly, let's do if p is less than 0. So for example, if I have p is equal to negative 1 this time, then what happens if I put the negative 1 into my equation? We have y is equal to x minus negative 1 whole squared plus q. Now the minus and the minus will then cancel out to become positive. So y is equal to x plus 1 whole squared plus q. Now I have been saying in my lessons that if this value is positive, if it's plus, then it's going to be a left shift. Okay, it's counterintuitive to what we usually think. We often associate plus as to right word and left negative as to negative. However, in this case, if it's inside the bracket of the squared, if the value is plus, it's going to be left. That's why the textbook, or the equation is going to be minus p. It tries to simplify things for you by saying x minus p, and so if p is greater than 0, it's going to be, if p is positive, it's going to be right words. If p is negative, it's going to be left words. They try to make it intuitive to you, but what happens if we have an equation, for example, let's say i.e. y is equal to x plus 3 whole squared. Now, what people usually associate with plus 3, now, oh, it's plus. It's going to be positive, which means that I'm going to do a right shift. Okay? But that is completely wrong. Okay? It is not a right shift. If you want to use the actual equation, it should be y is equal to x minus negative 3 whole squared. And so it's actually, I think that the equation form x minus p, it makes it more confusing. I would actually just look at the equation itself and then determine whether that value is plus. If it's plus, it's going to be left. So this is actually negative, which means that there should be a left shift. Okay, so I think the textbook makes it a little bit more confusing than it actually is. All you have to remember is if the value inside the bracket here is plus, then it's going to be a left shift. If it is negative over here, then it's going to be a right shift. Okay, so to me, and I hope that you would all find this less confusing now, that this is the actual way to do it. Okay, if you try to remember in terms of the p value, whether p is plus, p is negative, then you're going to have to re-put that into the x minus p, which means that if you have a p of negative value, then it's going to be minus negative, which means that it's going to be plus in the end. And the same as the other way around. So hopefully this clears up some confusion and some misunderstanding. So this is it. Okay, and your task for today is to complete or to do the formative quiz that I will send out. I have put up on Power School, okay, along with this video. Okay, so watch this video first and then do the quiz afterwards. Thank you.